So today you tried to find how many total squares are in this shape, and I asked you to do it systematically. So you all tried on your own. These were the different amounts you came up with, and in the end, 40 was correct. So if you count the teeny tiny squares and record that amount, then count all the 1 by 1 squares, of which there are 4 rows of 4 plus this one and that one to get 18. Then count all of the 2 by 2 squares. There are 3 in the top row, 3 in the middle row, and 3 with including the bottom row. That makes 9. Then count the big 3 by 3 squares. There's 2 on the top and 2 on the bottom. That's 4. And then there's one big 4 by 4 square. So if you do it systematically, you can be sure you didn't miss any. And that's just to get you to understand starting to find patterns by doing something systematically. Because today what we're really looking at are sequences and trying to generalize patterns to get to the nth figure. So the first pattern of toothpicks was a square that had just one square with 4 toothpicks, and then 2 squares that shared a side, which was made with 7 toothpicks, and then 3 squares that shared sides, which took a total of 10 toothpicks. So these are the terms, the toothpick shapes, and these are the term numbers, and what you want to try to find is a pattern between the term number and the term. So first you guys found a pattern going down. This is an arithmetic. What do I do to the first amount of toothpicks to get the second? Well, I add 3, and you can see the 3. 1, 2, 3 right here, and then I add 3, and I add 3. So we know there's some kind of a pattern with repeated addition of 3. And remember, repeated addition is multiplication. So we've got 2 groups of 3 here. We've got 3 groups of 3. The next one will have 4 groups of 3. So we were looking for some kind of a pattern. Then I said, well, imagine what the fourth figure looks like. And you guys started to see a pattern. There's 4 toothpicks on the bottom. There's 4 on the side. There's 4 on the top. And then there's an extra 1 on the outside. The third had 3 this way, 3 this way, 3 this way, and an extra 1. The 2 had 2, 2, 2 vertical, and an extra 1. The first term had 1, 1, 1, and an extra 1. So what we started to think about is the 100th figure is going to have 100 on the top, 100 on the bottom, 100 vertical, plus that extra 1 on the right side. So the nth figure is going to have n on the top, n vertically, n on the bottom, and 1 extra 1 on the right. And that's how we got to 3n plus 1. So for the nth term, we're going to have 3 of that number and 1 more. So we can just test that out. The third term was 3. 3 times 3 is 9 plus 1 is 10, and that's how we get the 10. The second term was 3 groups of 2, which is 6 plus 1 is 7, and that's how we get the 7. The fourth term would be 4 squares in a row, so that's 4 times 3, which is 12, plus the extra 1 on the right, which is 13. So that general pattern will work. All right, then we worked through the activity 2 in your book, and it looked like this. So we had a rectangle made out of toothpicks. The first term is 1 by 2, but we were looking for the perimeter. The number of toothpicks is the perimeter. So we had a 1 by 2 rectangle. The second term is a 2 by 3 rectangle. The third term is a 3 by 4 rectangle. The fourth term would be 4 by 5, etc. So now we're trying to find the number of toothpicks there are. So if you look at it this way, the first term had 1 toothpick here, 1 toothpick here, 1 toothpick here, 1 toothpick here, and an extra 1 on the top and the bottom. We're trying to figure out where the 1 is in the figure so we can see the same pattern with the 2. The second figure has 2 on the top, 2 on the side, 2 on the bottom, 2 on the right side, and the extra 1 on the top and the bottom. So look for a pattern. The third figure has 3, 3, 3, 3, and the extra 1 on the top and the bottom. So if you think of this as the nth figure, there's n, n, n plus 1, and n plus 1. And if we put all that together, we get 4n plus 2. So the 10th one would have 10, 10, 10, 10, plus those extra 2. The fourth one has 4, 4, 4, 4, plus the extra 2. So look at the pattern. We've got 4 groups of 4 plus 2 to get 18. We have 4 groups of 10 plus 2 in the 10th to get 42. So the nth figure has 4 n's plus 1 gives us 4n plus 2. All right, we looked at some dot patterns, and two different people looked at this in two different ways, and the question is, are they equivalent expressions? So we've got these series of dots, and the first person said, well, there's always 5 in the bottom, and then there's always these extra dots that are the same as the term number. So I've got 5 plus 1 for the first, 5 plus 2 for the second, 5 plus 3 for the third. So the nth would have 5 plus n, or 2n, or 2n plus 5. Let's see if I can get this out of the way. Scoot it over, and it doesn't want to move. Well, that says 2n plus 5. N plus 5. Another person looked at it a different way. She said the first figure has 1, okay, plus 1 more in the tower on the left and the right, and 3 in the middle. The second one has the same 3 in the middle, plus the second figure, so 2 plus 1, and 2 plus 1 on the left and the right. The third one has the same 3 in the middle, and then the figure number 3 plus 1 on the right, and the figure number 3 plus 1 on the left. So notice the fourth one would have 3 on the bottom, and then 4 plus 1 on the left, and 4 plus 1 on the right. So the nth is going to have 3 on the bottom, and n plus 1, and n plus 1. So the sum of that pattern is we've got the tower on the left of dots, plus the 3 on the bottom, plus the tower on the right. Is this expression equivalent to 2n plus 5? And one way to tell is to just test some numbers. So this was Allie's. So n plus 1 is a tower on the left, 3 on the bottom, n plus 1 is a tower on the right. This is Beth's, n and 5. So if we put in 10 for n, we can say 10 and 1 and 3 and 10 and 1 is 25. And if we put in 10 for Beth, 2 times 10 plus 5 is also 25. So these are called equivalent expressions. They have the same value for every number that can be substituted for the variable. So if I put 10 in for n here, I get the same value 25 as when I put 10 in for n here. I can also simplify this one. N plus n is 2n, and 3 plus 1 is 5. And I get the same expression, 2n plus 5. Then I asked you if these are equivalent expressions, k minus 8 plus 5 and k minus 13. And how do you test to find out? So we started by putting 10 in, or 20 in, excuse me. We started with 20, and 20 minus 8 is 12 plus 5 is 17, yet 20 minus 13 is only 7. And if I get two different values, the expressions are not equivalent. So we just decided to check one more. So if k is 10, here we get 7. If k is 10 here, we get negative 3, and they are not equal. So you use a number to test to find out if they're equivalent. And then the last one we did were, are any of these expressions rather equivalent? So we started off by just using 10, and for this one, 10 plus 3 was 13. 13 squared is 169. And the third one, 10 squared is 100, plus 6 times 10 was 60, plus 9 also gave us 169. So these were equivalent expressions because we got 169 when we substituted 10 for n. This one is not, though. 10 squared is 100, and 100 plus 9 is only 109. And then I tried to show you algebraically, when you square the quantity of n plus 3, it's n plus 3 times n plus 3. So if we want to use the distributive property and get rid of these brackets, we have to multiply this n in the first brackets by each term in the second bracket. So in red, n times n is n squared, plus n times 3 is 3n. And now I have to multiply the second term in the first set of brackets by each of these terms. So 3 times n is 3n, and 3 times 3 is 9. And now I have to add all of these terms together, the like terms. So I have an n squared, 3n and 3n is 6n, plus 9. And notice now this expression matches this expression. All right, you have a quiz coming up next class, so make sure you review lessons 1, 1, 1, 2, and 1, 3 for it. I'm adding in the commutative property. Make sure you know what that is, and I'll see you next class. And then this is the practice to do. So you need to get 5 topics and 1 hour in on ALEKS by Wednesday to have completed your homework. Even though your total time for the week's not due till Sunday, I'm telling you for homework, get 5 done in 1 hour. And then you also have 3 problems to do on pages 23 and 24. That's it.